Welcome to AI Frontiers. Today we explore computational linguistics, bridging language and AI. This episode unveils the science behind human-machine communication, focusing on fairness, trust, and multilingualism. Drawing from 46 recent research papers, including a deep dive into language models and psychiatry by Chen and colleagues, we'll discover how AI is reshaping daily interactions. AI models can now estimate psychiatric symptoms from interview transcripts, functioning almost like expert clinicians. These systems work across multiple languages and require no special training for each one. Imagine AI as a doctor's multilingual assistant, aiding in diagnosis and monitoring. However, this frontier raises important questions about trust, bias, and understanding. What really happens when your words meet a machine? Computational linguistics is the driving force behind digital assistants, translators, and chatbots. It shapes how technology understands and responds to human communication. Recent research in this field addresses critical issues such as fairness, efficiency, and transparency. Today's episode aims to unpack these advances and their real-world impacts, highlighting how your daily interactions with AI are shaped by innovations in computational linguistics. Visualize computational linguistics as a bridge linking linguistics and computer science. Researchers traverse this bridge, equipped with neural networks, statistical tools, and parsing algorithms. The field resembles a bustling library with shelves filled with linguistic data and machine learning models. It is continually evolving, introducing new data and addressing emerging challenges. The mission remains to make artificial intelligence systems fluent, fair, and humane in their use of language. Large language models, or LLMs, such as GPT, are the engines driving modern AI. These models generate and interpret human text at an unprecedented scale. Notably, Chen et al. Demonstrated that LLMs can predict psychiatric symptom severity, while Halperin et al. Developed methods to identify when models produce hallucinations, responses that sound plausible but are incorrect. LLMs are like race cars, capable and fast, yet requiring careful steering. The phenomenon of hallucination is a key challenge, when AI gives answers that sound right but are fundamentally wrong. Ensuring fairness and mitigating bias in AI are paramount, especially as these systems operate across diverse languages, cultures, and contexts. The POC-BBQ dataset, for instance, is designed to evaluate fairness in both Urdu and English, illuminating hidden biases in model outputs. Providing AI with a cultural guidebook rather than only popular references allows for more equitable and representative technology. Benchmarks such as these strive to ensure that AI systems truly reflect and serve everyone. There is a growing demand for transparent and explainable AI. Modern models increasingly justify their decisions, whether in medical diagnoses or legal interpretations, as exemplified by recent research. A useful metaphor frames AI as a math teacher who shows every calculation step. Explainability is crucial for building user trust, particularly in high-stakes domains. An important concept is zero-shot learning, where AI tackles entirely new tasks without prior examples, demonstrating adaptability and trustworthiness. Notable findings from recent research include Chen et al.'s work, where large language models matched clinicians in scoring psychiatric symptoms, functioning across multiple languages and at scale. Halperin et al. Introduced new semantic divergence metrics, effectively acting as lie detectors that catch AI hallucinations. Deng et al. Developed methods to efficiently trace the impact of individual data points on AI decisions, enhancing transparency. The PAC-BBQ benchmark pushes models to recognize and mitigate cultural bias, while Sun et al. Pioneered more efficient language model architectures to broaden global access. A standout paper by Chen et al. Tackled early detection of schizophrenia, a task marked by high stakes and complexity. Using transcripts from over 400 patient interviews in multiple languages, the team developed a zero-shot model, one that had never been exposed to specific psychiatric rating scales. This approach transforms clinical practice by enabling scalable, affordable, and accessible assessments. The concept of intra-class correlation was employed to measure the agreement between model-generated and clinician-provided ratings, underscoring the reliability of the AI's assessments. The Chen et al. Approach involves a language model that reads clinical interview transcripts and outputs symptom severity scores. This system achieved a median correlation of 0.84 with human raters, matching or surpassing clinician reliability. The model effectively handles multiple languages with only minimal reduction in performance. Including patient history as additional context further boosts prediction accuracy. The impact of this technology is significant. It enables clinics with limited specialist resources to offer early intervention and frequent monitoring, supporting better outcomes for vulnerable patients. Real-world deployment of these technologies is not without challenges. Clinical data are inherently messy, and privacy protection is critical. The model developed by Chen et al. Is designed to augment rather than replace clinicians, acting as a second set of eyes. This enables frequent, low-cost monitoring for patients at risk, but ethical use and wide accessibility remain important challenges. Ultimately, this work exemplifies technology serving as a positive force in mental health care, balancing accuracy, privacy, and human-centered care. The future of computational linguistics can be envisioned as a complex tapestry with threads representing power, fairness, and understanding woven together. The field is advancing toward models that can explain their reasoning, adapt to new contexts, and respect cultural nuances. Richer benchmarks are being developed to test not only factual accuracy, but also reasoning, empathy, and bias. Efficiency remains a central goal, with leaner models lowering barriers to entry. Ultimately, intelligence is defined not just by knowledge, but by the ethical and wise use of that knowledge. In summary, computational linguistics is the bridge that connects language and technology for everyone. Research by Chen et al., Halperin et al., and others is driving progress in fairness, trust, and transparency. Although the field is advancing rapidly, many open questions remain, particularly around ethics and societal impact. Listeners are encouraged to explore, question, and share their insights, as collective curiosity and engagement shape the next chapter in artificial intelligence. This episode was synthesized using advanced AI tools, including OpenAI GPT 4.1 for language generation, TTS by OpenAI for narration, and image generation by Google. All content has been reviewed by human experts for clarity and accuracy. References to all cited research papers are available in the episode description. Some oversights may remain, so critical engagement with the material is encouraged. The commitment to transparency and continuous improvement in content curation remains paramount. Subscribe to AI Frontiers for weekly updates on the latest advances in artificial intelligence research. Engage with thought leaders and fellow learners in the community. Share your questions and feedback with the team, and stay connected to the channel, AI Frontiers. Remember to stay curious, stay informed, and help shape the future of AI. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.